Welcome to the Deep Dive. This is where we take a whole stack of your sources, articles, notes, maybe some research, and we really pull out the most important bits, the key insights.
Yeah, we try to give you that shortcut, get you well informed, but maybe with a few surprising facts thrown in.
Exactly. And hopefully keep you hooked. Today, we're jumping into something that really touches all of us, whether we fly often or not. Flight. It's everywhere.
Pervasive.
But lately, it feels like we're hearing about more aviation incidents making headlines. It's unsettling.
It is. And we hear about crashes, near misses, but the details, that's where the real story is, right?
That's what we want to get into. Why do these things happen? What does it tell us about aviation safety today? That complex dance between incredible technology and, well, physics.
And the human element. Can't forget that.
Absolutely. So our mission today, for you, our curious listener, is to really extract the key takeaways from the sources you sent us, give you that deeper understanding.
And it's really important, I think, to frame this right. We're not just looking at a list of tragedies.
No.
These incidents, as awful as they are, they're like case studies.
Right.
Invaluable ones.
Right. Learning opportunities, in a way.
Exactly. They show us this incredibly complex mix of technology, human factors, which are often underestimated, and just, external circumstances, things you can't always predict. So from the start, we need to see this not just as what went wrong right then, but more about the layers, the decisions, the conditions leading up to it, the systems involved.
And how the industry learns from it, hopefully.
Yes, absolutely. It all feeds back into this constant, relentless effort to improve flight safety worldwide. It's a high-stakes reality we're discussing.
Okay, so let's begin this deep dive. We're going to focus first on a really compelling and, frankly, heartbreaking incident, the Bangladesh jet crash.
A powerful starting point.
It really underscores that human element we just mentioned. This happened July 21st, 2025. A Bangladesh Air Force F-7 BGI fighter jet crashed into a school.
Just horrific.
Yeah. So the day started, like many do, with what was supposed to be just a routine training flight. About 1:06 p.m. local time, this F-7 BGI takes off.
The base there in Dhaka, Kurmitola.
Right, BAF base, Barutum, AK Kanker. And at the controls, Flight Lieutenant Tukir Islam Sagar. And this is key. It was meant to be his first solo fighter mission.
Wow, first solo.
Yeah, think about that. His very first time flying a combat jet totally alone. It's a huge deal for any pilot. Massive pressure, massive anticipation.
Definitely. And the F-7 BGI itself. The BGI means it's one of the modernized export versions, right, for Bangladesh.
Exactly. Upgraded radar, better avionics than the older J-7s in space on. Still an older design fundamentally, but capable. Yeah. And these training flights were, common over the capital.
But this one went wrong fast.
Very fast. Only moments after takeoff, the sources say maybe 4 minutes in, something went terribly wrong.
A major technical malfunction. That's what the reports indicate. Struck the aircraft, caused it to stall, basically become unresponsive.
Imagine that. An aircraft built for speed and agility, suddenly just dead weight right after takeoff.
And the control tower, they reacted quickly, issued that command, eject, eject. Standard procedure when an aircraft is clearly uncontrollable. But, and this is the absolute crux of the tragedy, the plane was already flying too low. Dangerously low.
Right. Ejection seats need height to work properly.
Yeah.
For the parachute.
Precisely. Minimum altitude is critical. Depending on the exact F-7 variant, speed, attitude, you might need, several hundred feet, maybe over 1,000 in some cases.
And he didn't have it.
Seems not. Maybe only a couple hundred feet when the call came. Just wasn't enough altitude for a safe ejection.
So Flight Lieutenant Sagar knew the danger. He knew the odds were impossible.
Absolutely, he knew. But he fought it. Fought to regain control. His transponder signal showed him descending, not climbing.
He didn't just give up.
No. Even facing certain death, he actively tried to steer that jet away from the populated areas below, aiming for open ground. It wasn't just letting it fall. It was a conscious act.
Heroism, sacrifice.
Absolutely. A final act of sacrifice. Putting the safety of people on the ground first, even when his own fate was sealed. It speaks volumes about the sense of duty.
And the impact. It was devastating. Sometime between 1:10 and 1:15 p.m., the aircraft hit.
Right near the main gate of Milestone School and College, in the Attur area of Dhaka.
It struck the side of a 2-story building. And classes were still going on. A normal school day.
Unbelievable.
Can you even picture it? Hundreds of students inside, Kids aged 8 to 14, teachers, maybe parents picking them up.
Just chaos.
Total chaos. It tore through iron railings, smashed a huge hole in the building wall. The force must have been incredible. And seconds after the crash, a massive explosion, then fire, engulfing part of the building.
Thick black smoke.
Yep.
Visible everywhere. Panic.
Widespread panic across the neighborhood, people running, trying to find loved ones. And the cost, the human cost was just immense.
The numbers are staggering.
At least 27 people dead, including the pilot, and many, many school children, 8 to 14 years old.
And the injured.
Over 170 injured, many critically. Severe burns, crush injuries. It's just a horrifying picture of what happens when these systems fail over a civilian area.
It really is. And an incident like this, it forces you to ask bigger questions, doesn't it? Not just about the final moments, but about the aircraft itself.
Yeah, the F-7 BGI.
And maybe patterns in military aviation, especially with, older fleets, which brings us right to the aircraft.
Okay, let's talk about the F-7. As you said, it's Chinese-built, Chengdu Aircraft Corporation, multi-role fighter.
And its history is pretty significant. It's an advanced version, an export version of the Chengdu J7.
Which itself comes from the legendary Soviet MiG-21.
Exactly. A long lineage. The F-7 was designed to offer upgrades, avionics, pilot interface, weapons capability.
Aimed at air forces needing something capable but cost-effective.
Precisely. A way to get potent air defense without the huge price tag of, say, top-tier Western fighters like an F-16 or a Typhoon. For many countries, that's just not feasible financially.
So the F-7 was like a practical solution, a workhorse.
A real workhorse for many air forces, including Bangladesh, for decades. Affordable modernization.
But that workhorse status, that longevity, that comes with risks, doesn't it?
It absolutely does. Latent risks. Over time, even these modernized jets, like the F-7 BGI, they start showing fatigue, especially after, say, over a decade of high-performance flying, like this one had.
And this isn't just like needing a paint job.
Oh, no. We're talking fundamental physical breakdown. The materials, metals, composites, they degrade microscopically at first. Stress accumulates.
Where does it build up most?
Key areas, critical load-bearing structures. Think wing spars, bulkheads holding the fuselage together, landing gear mounts, engine mounts, places taking constant heavy stress.
And predicting when something might fail. That sounds hard.
It's a huge engineering challenge. Every flight, every maneuver adds stress cycles. Microscopic cracks can start, grow, often invisibly, until bang, fatigue failure, no warning.
Especially after maybe thousands of flight hours.
Exactly. That over a decade mark becomes a threshold where accumulated stress can really bite, despite maintenance checks. Predicting it needs fancy testing, eddy currents, ultrasonic scans. But even those have limits, especially on older designs not built with easy inspection access in mind.
So it's a workhorse, but an aging one with hidden dangers.
Increasingly insidious risks, yes.
And you mentioned another problem before. Spare parts.
Ah, yes. A massive headache. A logistical nightmare, really, for anyone flying older gear.
Because they stopped making the F-7 series when, 2013?
That's right. So finding new, high-quality parts gets tougher and tougher. It's not just supply. It's geopolitics, IP rights, factories just not making them anymore.
So what do maintenance crews do?
They often have to rely on refurbished parts, maybe secondhand ones, or even cannibalize take parts off other grounded planes.
That sounds risky.
It is. Because those parts might not meet the original standards. They might have their own wear and tear. Or worse, you risk counterfeit parts getting into the supply chain, look right, but aren't right structurally.
Which directly impacts safety.
Absolutely. Reliability, overall flight safety. How do you maintain readiness, keep pilots safe when critical parts are scarce, their history uncertain, quality may be compromised? It forces really tough choices, a global problem for many air forces.
And for the Bangladesh Air Force, specifically with the F-7, this isn't the first time, is it? Our sources mention a pattern.
Troublingly, no, it's not the first time. They've had several accidents with F-7 variants over the years.
And investigations often point to.
Mechanical issues,
Yeah.
frequently cited as the underlying cause, similar to what's suspected here in the Dhaka crash.
And then there was another crash, 2018.
Yes, and what's really striking, what our sources highlight, is the link between that 2018 crash and this 2025 one. The aircraft involved in both had similar service lives, both over a decade old.
That strongly suggests aging airframes, maybe combined with those maintenance issues, are a real factor.
It certainly points that way, a contributing factor to this pattern, yes.
So the F-7, it's a symbol of a long-serving fleet.
Okay.
But these risks, they're getting harder to ignore. Puts a spotlight on that challenge for nations trying to maintain capability on tight budgets.
It's a difficult balance, capability versus safety, often driven by economics.
Yeah.
And connecting this out, this isn't just about Bangladesh or the F-7, is it?
No.
No. The interesting thing is, similar underlying issues, whether it's aging equipment, system complexity, the human factor, these affect lots of aircraft. Fighter jets, civilian planes, helicopters. We're seeing echoes of these problems globally, even just in the last few months.
So Dhaka is like a specific, tragic example of broader challenges.
Exactly, a vivid microcosm. The aircraft might change, but the fundamental risks often resonate across different contexts.
Okay, that's a really important perspective. Which leads us into the next part of our deep dive. We've looked closely at Dhaka, but our sources cover a range of other incidents worldwide.
Each showing different facets of risk.
Right, so let's broaden out now. Look at some other recent events, starting with more mechanical problems and ejections, but with different outcomes for the crews.
Okay.
Our sources point to a pretty dramatic U.S. Navy incident, an EA-18 Growler near San Diego Bay.
Ah, yes, off North Island.
That's the one.
Okay.
Happened around 10:15 in the morning, Naval Air Station North Island, right near San Diego International. This Growler, from Squadron VAQ-135, had developed a, quote, severe mechanical glitch.
Doesn't specify exactly what, but common issues on FA-18 types can be anything from engine flameouts, hydraulic failures, major avionics problems.
And the weather wasn't helping. Light rain, fog, visibility down to just 4 to 8 meters.
That's incredibly poor visibility, extremely hazardous.
So critical error message pops up in the cockpit, warning systems going crazy. The two crew members, they had to make a split-second call. Eject. And it's not just hitting a button, right? It's a whole sequence. Handle pull, canopy jettison, seat fires.
Immense force.
They got out just moments before the Growler went nose first, steep angle, 60 degrees, straight into San Diego Bay.
Landing gear still down, you said?
Yeah, landing gear still deployed. Shows how fast it all happened. Huge splash of water.
And what's really, chilling about that one, the what if?
The near miss aspect.
Exactly.
Yeah.
That jet went down just miles from dense neighborhoods, Point Loma, Coronado, and critically close to San Diego International's flight paths, not just the naval base.
If they ejected seconds later.
Yeah.
Or the plane drifted.
It could have been catastrophic on the ground, civilian homes, maybe even hit another plane. It really highlights the pressure, those instant life or death choices pilots make, and thankfully, effective ejection systems.
Definitely.
And just a quick clarification, the EA-18 Growler, like in this incident, it's the electronic warfare version.
No, the jammer.
Yeah, basically. Suppressing enemy defenses, electronic escort, packed with special pods and antennas. Different mission than the FA-18 Super Hornet, which is the multi-role fighter version.
Similar airframe, different guts.
Different guts, different complexities, potentially different failure points, both cutting edge, both inherently risky operations.
Good distinction.
Mm-hmm.
And speaking of cutting edge, it's not just older planes or occasional glitches. Our sources point to a really worrying pattern with one of the most advanced jets out there, the F-35 Lightning II.
Ah, the F-35, yes.
It's starting to look less like bad luck and more like, well, a pattern, raising serious safety questions.
There have been several high-profile incidents.
Just this past January 28th, 2025, an $85 million F-35 crashed in Alaska.
An Air Force F-35A, the conventional takeoff one.
Yeah, happened about 12:49 p.m. during training at Eielson Air Force Base. Pilot got out safely, ejected okay,
Thank goodness.
but the jet, completely destroyed, wreckage burning on the base. And this wasn't the first.
No, there was the one in New Mexico, May 2024.
That's right. Crashed after refueling. Pilot was seriously injured in that one.
And the really strange one, South Carolina, September 2023.
Oh yeah, the Marine Corps F-35B, the vertical landing version. Pilot ejected mid-flight because of a malfunction.
But the plane kept flying.
Kept flying, pilotless.
Yeah.
For 11 minutes before finally crashing in a field.
Yeah.
That ghost flight was just bizarre. Deeply unsettling.
It really was. Shows some strange interaction between automation and failure when the pilot's gone.
So these incidents, culminating in the Alaska crash, they're really intensifying concerns about the F-35's overall safety reliability, especially given the cost and the tech.
It's fascinating and, yeah, deeply concerning. What does it mean when your most advanced, most expensive fighter shows this kind of pattern?
It makes you question the trade-offs, right?
Yeah.
Stealth, advanced capability versus potential vulnerability.
Exactly. The F-35's design is incredibly integrated, a system of systems, which is powerful, but
Also a weakness.
it can be. Unlike older jets where systems might fail more independently, here, a software bug in one area like its complex logistics system, ALS or sensor fusion, could potentially cascade into flight control problems.
Because everything's connected.
Tightly connected, problems can jump domains. The engine, the F-135, is unique too. Powerful but complex and has had issues. Even the stealth coding needs incredibly precise, demanding maintenance.
So maintenance errors become more likely.
Or at least the impact of a small error could be greater. It's not just minor bugs, it's a different philosophy. You trade some robustness for that cutting-edge performance. It introduces new ways things can fail, demanding incredible precision in software and hardware support.
Suggesting that maybe we haven't fully ironed out all the kinks in these super complex systems yet.
It suggests that pushing the absolute boundary of aerospace tech brings unforeseen complexities, even with rigorous testing.
Okay, that's sobering. Let's shift focus now from purely mechanical or system issues to incidents where human factors communication played a more central role.
Critical areas.
We're looking at the American Airlines Flight 5342, an Army Black Hawk collision, January 29th, 2025.
Near Reagan National Airport, D.C.
Right. Okay, so picture this. American Airlines 5342, the landing flight, is on final approach. Runway 33, really low, maybe 400 feet. Just moments from touchdown.
Most critical phase. Low, slow, configured for landing.
Exactly. Meanwhile, an Army Black Hawk helicopter call sign PAT-25 is flying too, possibly training. It's flying perpendicular to the airliner's path, following the Potomac River.
Which is a designated helicopter corridor there. Common traffic.
But here's the crucial difference, and maybe you can explain this. Their operating rules.
Ah, yes. Absolutely key here. The Black Hawk, PAT-25, was flying VFR visual flight rules. Meaning the pilot is responsible for seeing and avoiding other aircraft, looking out the window, basically, maintaining separation visually.
Okay, and the American Airlines flight?
It was IFR instrument flight rules. In controlled airspace like that, IFR flights generally have priority over VFR flights. The whole system relies on VFR aircraft actively spotting and staying clear of IFR traffic, which is often on very precise paths.
So the Black Hawk was supposed to see and avoid the airliner.
Correct. Now, moments before the collision, air traffic control at Reagan National saw a potential conflict on their radar. They called the Black Hawk, PAT-25, asking specifically, "Do you have the other aircraft in sight?"
And the Black Hawk pilot said?
Responded affirmative or yes, something like that. Said they did have the aircraft in sight.
Okay, so problem solved.
Well, that's what ATC likely assumed, but the investigation now strongly suggests the Black Hawk pilot had mistakenly identified a different plane.
Oh, no.
Yeah, maybe a plane taking off or another helicopter nearby. They thought that was the aircraft ATC was asking about. Classic expectancy bias, perhaps? Seeing what you expect or want to see under pressure.
So they thought they were clear, but they weren't looking at the American flight descending right towards them.
Tragically, that seems the most likely scenario. They didn't realize Flight 5342 was on a collision course. That critical misidentification, that breakdown in situational awareness despite the ATC call, it likely led to the Black Hawk failing to maneuver in time.
A communication breakdown with fatal consequences, even with all the rules in tech. Chilling.
It underscores how vital, accurate human perception and interpretation remain.
And we see another angle on human factors, maybe mixed with tech and weather, in the crash of that LJ-55 business jet.
Right, the medical flight, January 31st.
Yeah. Departed northeast Philadelphia, heading for Missouri. It's a Learjet 55, known for being fast, efficient, capable in bad weather. Took off around 6:07 p.m.
But ran into trouble quickly.
Shortly after getting airborne, encountered a technical issue. Again, specifics aren't fully clear, but could be engine problems, controls, electrical. And the weather wasn't great. Light rain, fog, visibility about 5 to 7 miles. Not zero, but enough to lose visual reference quickly in cloud. Now, the flight data shows something strange. The pilot, described as experienced, instead of, say, climbing steadily or troubleshooting, made a hard, descending left-hand turn with no correction.
That pattern strongly suggests disorientation.
Exactly. Likely confused, lost spatial awareness once they entered the clouds and rain. Without visual cues, pilots can get hit by illusions. The brain gets tricked.
Somnographic illusion is a common one in low visibility. Acceleration feels like pitching up, so you might push the nose down without realizing it, especially if you distrust your instruments for some reason.
So even in a capable jet, a technical glitch plus bad weather can overwhelm the pilot.
If situational awareness is lost, absolutely. If you lose trust in your instruments or can't scan them effectively under stress, just moments into the flight, it lost control, crashed near a mall, huge explosion. Shows how fast things unravel when human perception falters.
Wow.
Yeah, that LJ55 case really drives home the cognitive challenges. You have all this tech, all these instruments feeding you data.
But the brain have to process it under stress.
Exactly. And things like automation bias, relying too much on the autopilot, or expectancy bias can interfere. If a technical problem hits in bad weather, and maybe the instruments give conflicting readings, the pilot's mental model can just collapse. That hard, uncorrected turn screams severe loss of situational awareness, disorientation.
So how do you train for that?
It's constant reinforcement, instrument flying skills, CRM, crew, resource management, recognizing disorientation, trusting your instruments even when your body feels wrong, knowing when and how to override automation. It's about building resilience to that unexpected cognitive failure.
Incredibly complex. Okay, let's shift again. Now, looking at incidents where external factors, the environment, or even unbelievably a direct attack were the main cause.
Right? Things outside the aircraft itself.
First, Jigu Air Flight 2216 in South Korea, December 29th, 2024.
Yeah.
This one shows a real cascade of failure, starting with birds.
Bird strikes, a common hazard, but potentially catastrophic.
So the flight got permission to land, runway 1, coming in from the south. But ATC specifically warned them about bird activity nearby.
A crucial warning.
The plane made a slight deviation, maybe trying to avoid them, but no luck. Pilot declares Mayday. Hit a couple birds.
Engine ingestion is the big worry there. Loss of power.
ATC immediately tells them, go around, circle back, land on runway 19, coming from the opposite direction, southward approach.
Which wasn't their planned procedure. Adds complexity, especially under duress.
Exactly. And it's during this go-around, this repositioning, that another problem hits. The landing gear won't come down.
Maybe damaged by the bird strike? Or the forces of the go-around, hydraulics, wiring?
Could be. So
Yeah.
now they have no gear. They have to attempt a belly landing.
Extremely dangerous, high risk of fire, losing control on touchdown.
And that's what happened. It touched down hard, skidded, then crashed into the elevated localizer antenna structure at the end of the runway. Concrete embankment, too. Huge fireball. Though, remarkably, the tail section stayed mostly intact.
Allowed for some survivors, incredibly, but the timeline on this one is just
Wow.
shows how fast it escalates.
You have the details.
Yeah, the sources give a minute-by-minute breakdown. It's chilling.
Can we walk us through it?
All right. 8:57 a.m., ATC gives that warning about birds. Routine, but important.
2 minutes later.
8:59 a.m., pilot reports the bird strike. Mayday, mayday, mayday. Bird strike, go around. Immediate emergency declared.
Wow.
9 a.m. Just 1 minute later, they start the go-around, climbing away, and ask to land on the opposite runway, 19.
9:01 a.m.
ATC clears them for runway 19, new instructions.
Then the landing attempt.
9:02 a.m., they touch down, belly landing, about 1,200 meters down the runway.
Rescue crews.
It deployed incredibly fast. By 9:02 and 55 seconds, fire rescue is fully deployed, less than a minute after touchdown.
But it wasn't enough to stop the slide.
No. At 9:03 a.m., the plane overshoots the runway end and hits that localizer antenna structure, the concrete base. Catastrophic impact.
Just one thing after another.
A perfect storm. Cascading failures. The bird strike forces the go-around. The go-around reveals or causes the gear failure. The gear failure forces the belly landing. The belly landing leads to the overshoot and crash. It really pushes the limits of contingency planning. How many things can go wrong at once before it's unrecoverable?
A question nobody wants to answer in real time.
Precisely. Pilots train for single failures, maybe double, but multiple compounding emergencies in minutes. That takes extraordinary skill and maybe some luck too.
Okay. From birds to something far more sinister. The most disturbing incident in our sources. A civilian aircraft shot down.
Unthinkable, but it happened December 25th, 2024. An Azerbaijani civilian aircraft reportedly hit by a Russian Pantsir missile system.
How did this unfold?
Okay, so 10 minutes later, AM Kazakh time, Russian ATC in Rostov gets word the flight is diverting to Aktau. Bad weather at their original destinations. Standard procedure.
Then what?
10 minutes later, 10:53 a.m., Rostov tells the Aktau flight manager there's been an explosion on board the plane. An oxygen tank in the passenger cabin, reportedly.
An explosion inside the plane.
That was the initial report relayed, causing passengers to lose consciousness. Crew declared an emergency, requested immediate medical help on arrival. Aktau scrambled emergency teams.
But the timing suggests.
The timing implies the actual event, the hit, happened sometime between roughly 10:30 and 10:53 a.m., and the sources attribute this to a Russian anti-air defense system.
A Panzer missile. How would that work against a civilian airliner?
Well, the Panzer S-1 is a short-range system. If the airliner was flying at a typical cruising altitude, the system's cannons wouldn't reach, so it would default to using a missile.
It tracks it, launches.
Right. Tracks using radar or optical systems.
Yeah.
Missile launches vertically, then uses guidance, maybe radio command, to steer towards the target. Onboard sensors keep tracking. In this case, tragically identifying the target as the Azerbaijani airliner, despite, presumably, its civilian transponder codes and flight plan.
And the impact.
The missile has about a 25-kilogram high-explosive fragmentation warhead. It likely detonates near the aircraft using a proximity fuse. Huge explosion, cloud of shrapnel. Reports suggest it hit near the tail section.
Critical flight controls back there?
Absolutely. Rudder, elevators, stabilizer. Shrapnel penetrates the fuselage, severs controls, hydraulics, wiring. Catastrophic damage, destabilizes the aircraft instantly, uncontrollable descent.
Did they try to land?
The pilots apparently fought it bravely. They contacted Aktau ATC at 11:02 a.m., tried to make an approach, possibly twice. But contact was lost at 11:28 a.m., shortly before it crashed near the airport. Total loss of life.
It's horrifying. What does this mean for aviation safety protocols?
It throws everything into question, doesn't it? How do you protect civilian flights when they might become targets, intentionally or accidentally, in conflict zones? It challenges the most fundamental assumptions about the safety and neutrality of international airspace.
A terrifying new dimension of risk. Okay, let's try to bring this all together. We've covered a lot of ground, a lot of different tragic events.
From aging fighters to high-tech glitches, human error, environmental hazards, even deliberate attack.
Right. The F-7 crash in Dhaka aging plane. Maintenance questions, but also incredible pilot heroism. The Growler ejection near San Diego, advanced tech glitch, quick crew action averted ground disaster. The F-35 pattern, raising questions about the bleeding edge of technology and its risks.
Then the human element focus. The AA Black Hawk collision, communication breakdown, misidentification, the LJ-55 disorientation tech, and weather overwhelming the pilot.
And the external factors. Jigu Air's bird strike leading to cascading failures. And finally, that Azerbaijani airliner missile attacked, the unthinkable happening.
So what's the common thread? What does it all tell us?
Well, several themes keep popping up, don't they?
Yeah.
Aging fleets and maintenance, not just old planes like the F-7, but the complexity of maintaining new ones like the F-35. Critical human factors are huge. Pilot heroism in Dhaka, quick thinking in San Diego, but also disorientation, misidentification. The human is always central.
Yeah, absolutely.
ATC and communication, the Black Hawk incident, shows how vital, clear, accurate communication is. It can literally save lives.
Or cost them.
Yeah. And finally, environmental and external threats. Birds are one thing, but a missile attack, that's a whole different level of unpredictable external danger.
Right.
So for you, our listener, hopefully seeing these different angles helps understand that aviation safety isn't just one thing. It's this complex, multi-layered system where technology, humans, procedures, and the environment all interact constantly.
It's a dynamic challenge, always evolving, which leads to that reflective question, doesn't it? How do we balance progress, the drive for speed, stealth, efficiency, with the absolute need for safety?
Yeah, where's the line?
And what new challenges come with crowded skies, drones joining the mix, increasingly complex AI in the cockpit? The F-7 issues show problems with old tech. The F-35 shows potential problems with new tech. Human factors remain constant.
But overall, flying is still incredibly safe,
Yeah.
statistically.
Amazingly safe, yes. And that's because the industry learns rigorously from every single incident, every near miss. It's built on continuous learning and adaptation.
But it's a constant battle.
A constant battle against variables you can't always predict, against the limits of machines and the limits of human performance under pressure. The margin for error is just so small. These events are tragic reminders of that.
So what does this all mean for you, listening now? Maybe think about how this changes your view of flight, of safety. Next time you look up at a plane, maybe you'll see more than just metal. You'll see the incredible complexity, the dedication, the constant effort involved.
And a final thought to maybe leave you with. As air travel grows, as skies get more complex, what's our role as informed citizens? How do we understand this balance between progress and vigilance? And looking ahead, what innovations, maybe in tech, maybe in training, maybe in international rules, or even geopolitics, might be needed to tackle the kinds of risks we've talked about today? How do we keep the skies safe for everyone in the future?
Lots to think about.
Thank you for joining us on this deep dive into these recent aviation incidents. We hope you feel better informed and maybe even more curious about the world above us.